Hi guys, welcome to TV Coder channels. For this video, I'm going to show you how do I work on the data understanding part for the each gender data sets from kaggle. Let's get started. Hi guys, welcome to my videos. For this video, I'm gonna fully focus on the age, gender, and ethnicity CSV face data sets that coming from kagglers. For this dataset, you can get from the Kaggle website, which this will be the URL, and I'll be paste the link in the description below. First of all, what you're gonna do is just to download this dataset. It consists of around 200 MBs of dataset. I have pre-downloaded the dataset to the specific folder that I'm gonna work on for all my TV Coder channels Kaggle datasets. I will push to the GitHub later on as well. After you have been downloading the age gender dataset, so let's open it up and have a quick check on it, what it consists inside this folder. So for this dataset, we have around 5 columns, and it consists of age, ethnicity, gender, the image name, and also the pixel itself. So for the pixel cells, it's actually representing each pixels of that particular images. So we're gonna extract this image later on and save in a folder we're gonna set for to storing our image data. And then this will be the labels. And yeah, it just consists of 1, 0, 2, 3, 4. We doesn't know what represent what. We're gonna refer to the website and have a check on it whether what represent what. Okay, we come to this website and let's have a look on the description itself. So this particular author says that he's working on the UTK datasets, and he found that there's quite a lot of different folders, right? So it's also require a lot of data cleaning and preprocessing. So he's trying to make it simple for all the user, and I believe this dataset is only partial of the original full dataset. So I have been search for this UDK face dataset as well. You can come to this particular website if you are interested. I will also paste this link in the description below later on. Right. So yeah, the original dataset is actually consists of large scale fetch dataset with long age span. So it's ranged from age 0 to 116 years old, and it consists of 20,000 face images with annotation. Of course, the annotation will be the age, gender, and ethnicity. The dataset purpose is used to target several domains like face detection, probably age, and progression, landmark localization, and etc. For this video, I'll be doing 3 types of label prediction in a one single network. So yeah, this is the plans that I'm gonna do for these particular data sets. Okay, so the highlights, it consists of 20K of face images in the wild. So only single face on image, meaning that there's only one face on one images. So for this dataset that we are downloading from Kaggle, they are I will assume that it already been pre-processing. So we have not much gonna do with this original dataset, but just a reference so that we can actually refer to the label formats. From the age, it will be just a random number range from, let's have a look. That range from age 1 until age 116. So it consists quite a lot of different number. All of them will be a unique number instead. It's not like categorical. It's just a number of age from range 1 to 116. So for this particular label, we're gonna doing regression instead of classifications. For the ethnicity, so it only consists of 0 to 4. So we have 5 categories, and we need to check whether what category it represents for each indexes. When we come back to the UTK face website, so we can see that there is a race there, and it's an integer from range of 0 to 4, which match to the ethnicity columns that we have in this particular CSV data sets. And then it denote that it represent for 0 is white, 1 will be black, Asian will be 2, Indian will be 3, and then others. And the gender, 0 represent male and 1 represent female. So yeah, we're gonna train on these 3 particular labels in a one single neural network. Well, after we have been understand the basic idea of each label represent what, and then this will be the data set, we're gonna start our work in the Jupyter notebook. So the very first thing that we're gonna do is open up our Anaconda prompt, and then I'm gonna navigate to the directory that I'm gonna work in on. Okay, beforehand, I actually already created the environment. Then I'm gonna activate my Conda environment. Once we have been activate our Conda environment, let's start our Jupyter notebook. Okay, let's create a Python 3 notebook, and I'm gonna say name it as a data understanding. Let's import our libraries that we're gonna use as PD pandas as usual, because we're gonna read in the CSV. Then we're gonna make use of NumPy as well, SNP. Then we're gonna leverage the OS package as well. Then for this video, we're gonna make use of CV2, which is OpenCV. Let's run this. So the very first thing is we're gonna read in our dataset pandas.read_csv. Then I'm gonna put in the name of our CSV, which is h_gender.csv. Let's print the data frame out and make sure it's working. Right, it's working. And the next things that we're gonna do is create the mapping for the gender and also the ethnicity class. So start with ethnicity first. Then we're gonna refer to here. 0 is white, so we're gonna put 0. Next will be the gender. Next, we're gonna create a functions. I will name it as extract single row, which later on we can look through the data frame and extract the image one by one, include all the labels that tagged to this particular image. Then I will need to pass in a parameter. I will say a single row, so I will name it row. Then I'm gonna get the age of the row, so by referring the column of age. And then next will be ethnicity, the row of ethnicity, and the gender. We want to get the image name as well. We're gonna extract the image, which we're gonna make use of the NumPy array, and we want to say NumPy.array, the row, that name of pixel. Then we're gonna split it. Then we're gonna make sure it's uint8. And because of the image is in just a single row, we want to make sure it's in image form, that it have the shape of 48 by 48 by 1. So meaning that you have the row columns you have the rows of 48 and also columns of 48, and it's only one single channel, which is grayscale, from the range from 0 to 255. Then we're gonna call image.reshape. Yeah, so by doing this, we able to change the NumPy array to have a column and row of 48, 48 by 1. Last but not least, we're gonna return the image on the age, ethnicity, gender, and the image name by replace .jpg .chip.jpg into .jpg. Then next, what we're gonna do is first create a gender distribution mapping that we want to check whether how many male and female consist in this data set. So we will everything start from 0. The next thing, ethnicity distribution. So for this, I'm gonna say white. It will be an empty list. From here, we're gonna start to extract every single row, and we pass it into our extract single row functions to process. Our img h ETH, ethnicity, gender roles, and also image name will be equal to extract single row. And then we're gonna pass in our df.ilog, the index. Then next, I'm gonna create the save image name, which will be the new name. I'm just gonna append the label information into the name of the images itself. So we're gonna use the ethnicity map. We're gonna pass in the index of the ethnicity, then we append with a underscore. Then we're gonna use the gender map, and then pass in the gender plus the age, so just to make sure it's in string, and then underscore again, then plus the original name of the images. Right. Then for the ethnicity distribution list, we want to append it. Sorry, it will be referring to the ETH. When it comes to ethnicity distribution map, then it will refer to the current ethnicity. Let's say if it's white, then I will come to this white and start to do append of these particular images. So it will be a tuple. I will put in the image and also the save image name, because all the label information are appended in the name of the images. So later on, we're just gonna perform save the images with this image name, and we have all our information into our every single images. Then for the gender distribution, we're gonna pass in the gender instead, plus equals to 1. So for this line, what does it mean is when it comes to these particular rows and referring to the gender and map back to the gender distribution, let's say it's a male, right? So we know that this image is the male, and then we will increase the count. So just to check the distribution on after finish processing the whole data sets. We just want to know the amount of the male and also and the female consists in this particular data set. Once we have been go through all the data sets, then we're gonna print out the gender distribution. Then we're gonna look through the ethnicity distribution. We're just gonna print out the name of K space and then the length of the list. Okay, let's run this. Right, so I'm so sorry for the syntax errors there now. There are some missing part that I forget to do. Well, instead of passing the ETH itself, because the ETH itself, right, the ethnicity itself is just representing in a indexing. So when we come back to the distribution mapping, so it don't have the indexing. So it just have the string only. So in order to get the string, actually we need to make sure that we get the index name, or we get the name by passing an index in the ethnicity map to get the string itself. Then this will be getting, for example, let's say is a 0, right? So when we get a 0, when we referring to the ethnicity map, it will be white. Then this will be white. And then when we go back to the ethnicity distribution mapping, then when it comes to white, so you're only able to refer to this particular list and then do other append of image and also the image names. So same for the gender. So we still need to get the gender map for either it's male or female, and then referring to here to this gender distribution mapping, that we only able to this to do the increments of the particulars male or female's keys. Yeah, once we have been completing to run these cells, so we can see the gender distribution. For male, we have around 12,000, and then for female, we have around 11,000. And then for each ethnicity distribution, we have quite a lot of white peoples, around 10,000 plus images that is coming from white. Then the black people, we get around 4,500. Then for the Asian, we have 3,434. Indian, we have nearly to 4,000. And for other, it only consists of 1,600 plus. Right, so this is all the distribution consists in this particular data set. So in apps total have around 23 to 24,000 of data sets. Okay, what's next? We're gonna do the train test split. So meaning that we're gonna split this data set into three particular parts. One will be the training set, another one will be the testing set, and another one will be validation sets. So my strategy here will be doing a 70% of train, 15% of test, and also 15% of validations. All right. So in order to save our image to directory, so I created a directory in my desktop, and then inside this particular directory, I'm gonna create another three folders. One will be train, test, validations. So we're gonna have these three in order to store our images from the CSV datasets. The next things that we're gonna do is import some extra library like max and import the random, because we're gonna make use of these particular packages from Python to actually reshuffle all our lists. Then we're gonna create the train directory, will be os.path.join. Then we're gonna make sure that we have safe directory. We have mentioned our root right directory. Then we're gonna join the safe dir with train test dir test valid dir. Next, we're gonna create a function that saves our image to directory. That is gonna take in our image list and also the save directory. For index and the content in enumerate the image list. Then we're gonna use cv2.imrate os.path.join our save dir with the image list that we know that the second index will be the name of the images, and then we want to save the images if cell. Then next, we're gonna look through the ethnicity distribution mapping again, so that we can go through each of the ethnicity lists. Our current data set will be, then we just gonna shuffle our data sets. Then I'm gonna say this is a 15% will be the length of data set times 0.15. Then I will say test set will be our data set from 0 start until the first 15%. Then our validation set will be from our data set, start from our 15% set until the 15% set times 2, which I'm just gonna say plus. Then last will be our train set. It will be our data set start from D15 plus 15 until the end. Once we have been split out the tree set, which is the test validation and train set, then we can proceed to directly save our images to the directory. Then we're just gonna invoke the functions that we have created just now, which is the save img to dir. First thing is pass in our image list. I'm start from test set first. Then the save directory will be test dir. Second one will be validation set. And then our valid dir. Last one will be save image to the train set. And then our train directory. Right. And then we are ready to go. Let's run this. Okay, so one error here is we just want to make sure is in integer because indexes cannot have float. So when we times with 0.15, the output will be in float type. So yeah, we just want to make sure instead of int, I will say math.float. Then we run this. Sorry, so this should be content instead. Alright, so yep, after the cell 7 have been completing, so let's check our directory. So we first go to our train sets. So we can see it consists of around 16,600 items, right? 16599, right, of images, which we abstracted out from the CSV datasets. And then let's check for the test set. It consists of 3,553. And then last one will be the validation. Yep, so it's 3553. So we get here 70% here for train, 15% for test, and another 15% for the validations. Until here, I think we are ready for our next step, which is the model training. So I'm gonna see you guys in the next videos, and thanks for watching. Bye bye.